boundary of Vn. Here is the boundary of by construction. Is the boundary of Vn plus 1. Assume that this is y, and we have y is related to some z, for example. So it cannot be, because centers of bracket cannot be joining through an edge. This is the tree case. So the bracket at z is at y is this bracket. We define the past as this part is the past. The present as this part. There's 3 points. And the future, the rest. That means that the future is the complement of Vn plus 1 for in y. So our aim is to find Markovianity with respect to the fine structure of the graph. If we get Markovianity with respect to the fine structure of the graph, it means that it's very interesting Markov field. So then we define the following map. This map defined through this numerical conditional expectation and this operator, ky bar is the same as ky cap n1. So we want to go from inside to outside. To remove the part in the boundary of Vn and the part of the boundary of Vn plus 1, we need to shift the expression through this numerical conditional expectation. Because this map acts only on the bracket. Outside of the bracket, it acts trivially, means everything is fixed. So we prove that this map is a quasi-conditional expectation with respect to this tripole. Then, here the crucial point, the difference between this construction and the last one. Here, these maps does not commute, even in the simplest case. The simplest case is where k is the sum of 2 factors. Otherwise, if it's only one factor, it will be product mistake. So, in this case, and we assume that we have this situation. This is y, and this is z, and this is x. It means that the intersection of the bracket at y and the bracket at z contain only one point from the boundary of Vn. This is the simplest case where the two brackets have intersection. Even in this case, if we compute Et of z composite Et of y, we get an expression. This part depends on y, and this part on z. It's clear that the expression is not symmetric with respect to y and z. Therefore, the two maps do not commute. Even in this simple case, we have non-commutativity. So our construction admits a strong dependence on the fixed order. Then, for using this nice property that the boundary of Vn, the external boundary, is the union of all elements Z of this level, and if we fix the external boundary, this one is automatically fixed by the bracket at this level, and this one also means that the boundary of Vn is the union of intersection of brackets of element of the external boundary with the nth level. And here also with the n plus 1 level. So using this property, we define also this map. Of course, with respect to the fixed order, we define this direct product, and we may check that this map is also quasi-conditional expectation with respect to this triform. It means that this map acts on this set. Otherwise, it acts trivially. So, this map take this level and make it here. This is the action of this map. It go from inside to outside. Then we define the following sequence. Phi 0 is our initial state, and phi n is phi 0 of phi n until E01. We have at least one limit of the sequence by compactness of the set of states over A for the Weck-Serre topology. So at least we know that there exists at least one Markov field, but we need uniqueness. For the uniqueness, we compose some condition. For the uniqueness, we compose the following condition start. So assume that this map is in some sense projective or compatible with the state phi 0. Here is phi 0, the fixed state. So if you have phi where A is the horizon in this curve, phi 0 of E is equal to phi 0 of A. So under this condition, we get uniqueness of the limit. But this condition also is taken with respect to levels. We need a refinement of this condition to get Markov unity with respect to brackets, which is the final one. So then we pass to another